Traditional flat displays show a 2D image. Using optical components, integral photography displays emit a 4D light field, creating a view-dependent impression. We introduce a 4D design which passively reacts to illumination, relighting an image in real time. In extension of that idea, we will later show a display which provides a 6D viewing experience, varying with both illumination and observation angles. All of our designs are fully passive. They do not require electronics and use optics instead to convert the incident light into the desired image. This is a prototype of the 4D display. It uses a main lens array to map the incident light field into a 2D plane, where transparency modulates the light depending on the location and the incident angle. The modulating pattern is embedded in a corrective lens layer, projecting the image of the main lenses on a diffuser screen. As this simulation shows, the pattern modulates according to illumination direction and pixel location, independently from one another. The corrective lenses keep the light beam on the diffuser in place. A simplified design omits the corrective lenses, but adds a view-dependent transmission screen for improved contrast. We now demonstrate the simplified design. Note how the highlights, caustics and shadows move as the incident light direction changes. A different kind of 4D display projects out different patterns for different illumination directions. It uses a single big lens to focus an incident light beam on a small lens inside an array, where the light field is modulated according to the outgoing direction. Please refer to the paper for details on the functions of the other components. We use a spotlight to illuminate the display, which modulates the light field in the angular domain. This is observed as a pattern projected onto a diffuse screen. Note the high detail of the letters. The transparency, which contains the entire pattern, is in total only 2.5 cm square. Combining 49 of these single pixel blocks yields a 7x7 6D display. We will now keep the illumination fixed and move the camera. Observe the color shift from green to magenta. This indicates that we control the emitted light field along 4 dimensions. As we keep the observer position fixed, but move the light source, we can generate different patterns demonstrating the 2D illumination dependence. This is a time-lapse video of the 4D prototype mounted to an office window. As the sun moves over the sky, the highlights on the bottle cap, the shadows and the caustics move naturally in the image. Thank you for your attention.